Get started in about a minute. In about a minute. Prudence, I graded your tests. You had a few mistakes, not many. Jace, I graded your test. 11 times 12 is not 121. You made that mistake 3 times. The test was fine, but you just made some silly mistakes. 11 times 12 is not 121. Okay, here we go. Quick warning to the following people: Julia, Nathan, Grayson, Jenna, Lucia, Donovan, Priscilla. I think that's it. Oh, one more. Hannah. You guys did not take your test. If I do not get your test, I am cutting you big time slack. You don't get to do the test when you want to do it. You get to do the test when it's supposed to be due. And it was due 2 days ago, and you have not turned it in. I can see all of you have looked at the test, but none of the ones of the names that I called off did their test. Everybody else did their test. If I don't get it, it's 10 o'clock right now. If I do not get that test, by let's say 8 o'clock tonight, I am putting zeros in the grade book. We got to stay on top of this stuff. For the rest of you, good job turning it all in. I will have it graded. I started grading it this morning. I will have it graded by tomorrow at some point. Um, Here we go. Very quick class today. Very quick class. I'm going to have to, since these are graphs and a couple of answers, I'm going to have to look at your homework. I'm not going to call out the answers, but if there are any questions, I will entertain them right now. So, any questions on 12.1, the bar graphs and the line graphs? Or, sorry, just bar graphs. All right, so we're going to get started. Let's see, this is what the calendar looks like. I have now updated it from the latest and the greatest information for CMAS. All next week, we're still in quarantine. We're going to get back on that Monday. I don't think they were talking today that they were probably going to do CMAS. This is incorrect. They're going to do the CMAS on Tuesday, Wednesday, not Monday, Tuesday. I'm not sure why I put it on Monday there. They told me yesterday. Yeah, they didn't want you to take the CMAS on the very first day back. So it's going to be Tuesday, Wednesday. So 12.6B will be on Monday. We'll do that on Monday. And then on Tuesday, Wednesday, you'll take that CMAS. We're talking about next week. We're talking about the following week. You'll take CMAS then. And as you can see, we're going to finish up with chapter 12. And then we will move on to the polynomial chapter. And that'll take us to the end of the year. All right, so what do we got going on today? We got 12-2. It is probably one of the shortest classes of the year. So go ahead and write down your homework. Okay, and the last chapter of the book is chapter 13. Not a necessarily a requirement before Algebra 1, but it's a darn good preview of what Algebra 1 will look like. So we will get, I don't know how far we'll get into chapter 13, but that's how we'll end the year is on chapter 13. And then you guys will be in Algebra 1. Crazy. I remember teaching you last year, 7th grade. As I said, today is a quick and easy class. You should already be familiar with line graphs. You've seen them before, even if you don't know that's what their name is. You've seen these things before. You've used them in both history class, science class, heck, maybe even language arts class. You've seen these things. Just two things. We're going to make a line graph and a double line graph. Remember yesterday we made a bar graph and a double bar graph. It's going to be the same thing, just with line graphs. So recall in your notes, make sure this is in your notes if it's not in there from yesterday. that this entire chapter we're going to be dealing with data. Data is both singular and plural, and data are facts about objects. Data can be numerical or non-numerical. As I said before, how old you are is a numerical piece of data. Your favorite color would be a non-numerical piece of data, but both of those are facts about you, and well, you are an object. All right, that is what data is. What we do with data, we collect data, and then we try to make sense of the data. For instance, if I was trying to figure out, I want to buy all you guys lunch, and I want to figure out what to buy you guys, I would probably collect some data. And that data would be from each individual person, write down what you like for lunch. And all together, if I compiled that data, it would just be a string of information or facts, right? What I do to make decisions based upon those facts is I compile statistics. How many people wanted pizza? How many people wanted tacos or something like that? And that is what this entire chapter about. It's about statistics, interpreting that data. And the main thing that we have to interpret data or statistics are graphs. And graphs are a way of visually identifying or visually arranging that data. A picture is worth 1,000 words. And when statistics are graphed, very quickly you come to a level of understanding about those statistics. Hey, look, the graph is going up, or look, hey, look, the graph is going down. You get that all from a visualization of the statistics, which are compiled from the data. If you're just looking at a whole bunch of numbers, a lot of times it's hard to understand what's going on. Turn those numbers into statistics, turn the statistics into a graph, and it's really easy to understand what's going on. As I stated yesterday, of the two things that you do as an adult mathematically, no matter what your job is, arithmetic and statistics are the number two things that you do as an adult, like for the rest of your life. If you get into a technical field, there's plenty more math you'll do. But if you're in a non-technical field, you're still going to have to do arithmetic, add, subtract, multiply, and divide, and you will encounter statistics and graphs the rest of your life. So this chapter, let's see, it's just about making graphs. Yesterday we made bar graphs. The rest of the chapter are line graphs, stem and leaf plots, box and whiskers plots, and histograms. So today we will do the second one on that list right there, line graphs, line graphs. All right, you don't need to write this down. You wrote it down yesterday. As a reminder, a bar graph is, well, it's a graph using bars, rectangles. And those rectangles are numerically scaled. So for instance, a short one has a small number, a tall one has a larger number. And the scaling there is based upon the statistics, the data that you collect about those objects. Almost universally, the only time that you'll use bar graphs is when you have non-numerical data. How many people are from Los Angeles? How many people are from Chicago? That sort of thing. That makes for a great bar graph. All right, so here's an example. This is, I don't know if it's people's favorite fruit. Blueberries are favorite. I'm not sure about that. But yeah, this is an example of bar graph. Notice that it's categorical, the data. It's not numbers. It's apples, oranges, bananas type thing. And how many people like apples, so forth and so on. And this is your perfect example of a usage of a bar graph. Remember, bar graph, there is space between each rectangle and the height of the rectangle called a bar. The height of the bar represents that specific data point or that statistic. So we can visually identify very quickly that apparently, according to this graph, that more people like blueberries than any other fruits. And people think grapes are horrible, apparently. That's why I don't buy this. Okay. Today we're going to do line graphs. Line graphs are very similar to bar graphs, very similar. All right, now we come to what we need to write down for today. By the way, in this e-learning mode, boy, do I like to talk fast. So it's up to you guys to slow me down if I'm talking too fast. Make sure you say, hey, slow down. Give me a minute. Also remember that I will post the video, not immediately, but pretty quickly after the class. Obviously, certainly every day by 3 o'clock, all the videos will be posted. It just sort of kind of depends on how long this class goes. I've got a class immediately after this. So if this class doesn't end early, then I don't have time to post the video until my lunch break. My lunch break is at 12:15 every day, except for Fridays. Let's see, when is lunch on Fridays for me? 12:05. That's when I can post some videos. All right, back to the class. Write this down. So today we're going to be doing a line graph. A line graph, well, it's a graph, obviously. It uses a line to show how data changes over time. A bar graph is a graph that uses bars to show how data changes over time. So the only difference between a line graph and a bar graph is that instead of bars, you get lines. The data will contain two values for each data point. In other words, it could be numerical, non-numerical, and then it's going to be a compilation of, for instance, how many people like oranges. So you'll have a category for oranges, and then you'll have a number associated with, for instance, how many people like oranges. So that's that second sentence there. The data contains two things. One of them could be non-numerical, but the other one will be numerical. Those are line graphs. It's the same as a bar graph, just substitute the word line and bar, and it's the same definition. Once again, why are we doing this? Well, we want to see how the data changes over time. The line will go up, the line will go down, the line will stay horizontal. A horizontal line means that nothing is changing. A vertical line means that, something's changing, we're increasing. And I shouldn't say a vertical line, a line that goes up from left to right means that the data is increasing, or the frequency of something is increasing. And if the line goes down from left to right, then something is decreasing. All right, so those are the definitions of line graph and the purpose. And like I said, this literally reads exactly like it did for bar graph, except it has the word line instead of bar. All right, tonight for homework, you will have to create line graphs. If you made bar graphs, you can make line graphs. It's going to be the same steps as previously. If the data isn't in a table, you got to put it into a table first. Then you need to figure out the scales for both your horizontal and your vertical axes. Once that's done, you can make your graph. Now, I'm leaving out some detail there for create the graph. Most of it's self-explanatory, so how about we do one? We're only going to do two today. How about we do one, and then we will understand the process a bit more clearly. Remember, this is being recorded, so if you're a little bit unsure about something, play the video again while you're doing your homework. You can pause, rewind, fast forward, that sort of thing. All right, so here's my data, and Merry Christmas again. I gave it to you already in a table. The first step of doing this is simply to read and make sure you understand what's going on. It says school enrollment in the United States. That means how many kids are currently in school for the specific time periods labeled. So we got time periods from, it looks like decades again. No, it's every 5 years. So we got from 1960 all the way to 1995. As I stated yesterday, almost universally, if there's time involved, time is your your x-axis. Your y would be your actual numbers. Now you're like, hey, look, we got numerical data for both the x and the y, and that's true in this case. But we could have non-numerical data also for the x-axis. All right, they're giving us students in millions. And as we look at this, we can kind of see the numbers go up, they go down, sort of, but it's not really clear what the pattern is. How about we make a graph to fully understand the pattern? Okay, so step number one was put it into a table, done. Step number two was figure out the scales for both the X and the Y. So, well, it's pretty clear for the X-axis. We start at, 1960, and we go all the way up to 1995. And it looks like we're doing it in 5-year increments. So it kind of makes sense that for the x-axis, we start at 1960 and we go to 1995 by fives. For the y-axis, okay, the numbers aren't too friendly. The smallest number here is 42.2, and the largest number looks to be 51.3. So I need a graph that can contain the numbers 42 all the way up through, 52? And why am I going above 51.3? Because the graph has to go up to at least 51.3. Now, 42 to 52 are, well, those are kind of weird numbers. So I'm going to show you another technique of how to handle when the numbers are kind of weird like this. Like they don't start at 0, they start at 42. and they go up to what, 52. So my technique is this, to make the graph. Do you see this thing on the lower left-hand side? Looks like a Z. This is called, in statistics world, in the graphing world, this is called a break. Why is this not clicking? There it goes. So this thing right here, this Z, is called a break. And it's showing not a break in the horizontal axis. Look, it's on the vertical line. So it's shown as a break in the vertical axis. Now, some of you probably have already seen this and how this is used, but this is how it's how you use it. Well, obviously, right here at the bottom, that's your 0 for both your X and your Y. But as we go vertically, I might not want to start the next one to be 10, right? I might instead want the next one to be, I don't know, we could go 40 maybe. We could, if we start it, instead of 10, we start at 40. Well, there's a break between 0 and 40. And what you're indicating that the next one, if the first line was 40, you would think, well, the next line should be 80. But that break indicates that I'm not starting, I'm starting over again. In fact, that 40 is my starting point. And from there, I'm going to set a different scale just for my vertical axis. So, I mean, this is a technique that you use when you, I mean, look, the data is pretty close together, 42 to 52. But if I were to literally start at 0, I have a whole bunch of dead space. So this is called a break. So I'm going to start at 40, but I'm going to go up by let's see. I'm sorry, I did my x-axis first. So you can see here I'm going to go by 5s. You can see we're 65, 70, 75, 80. Notice I didn't write all the numbers, and that's a valid technique. I could even put 60, 70, 80, 90 if I indicated in my labeling that that's what I was doing, that 60 represents 1960. So on my vertical one, I could start at 40, I could start at 42, I got to go up to 52. So let's see, 42, 44, 46, 48, 50, 50. Yeah, I could go up by 2s. You see what I'm doing here? That break there indicates the first line there isn't 10 or 20. The first line there is 42, and that therefore the scale changed right there. And the reason why I'm allowed to do this is because there is no data points lower than 42. All right. So that's what I'm going to do right there. And then all I'm going to do is the same thing I did yesterday, but instead of making rectangles for my bars, I'm going to put dots for points. So my first point, let's see, where am I getting my first point? My first point is that first column right there. So that first column right there, I've already got the dot there, says that at 1960, we're at 42.2. So therefore, I'm going to be halfway up would be what, 43. So I'm not halfway up. So I'm a little bit less than that. The next point I need is at 1965, I need to be at 48.5. So 1965 would be the next line over to the right, and I need to go to 48.5, about right there. Now, these are as close approximations, right? They're not perfectly aligned, but they're pretty darn close. The next one at 1970 is 51.3, so slightly larger. Now, why didn't I put it directly above 50? Because remember, midway would be 51, and I'm at 51.3. I'm going to continue that process point by point by point. At 75, I'm at 49.8, so I'm almost at 50. At 1980, I'm at 45.8, so about 46. Where's 46? Well, 40, I'm sorry, a little bit less than 46, sorry. A little bit less than 46. At 85, a little bit bigger than 43. Where's 43? That's halfway between 42 and 44, but a little bit higher because it says 43.7. 1990, well, I'm above 46, so slightly above 46. You could argue about that dot placement there. And the last one is 50 and a half, 50 and a half. Okay. So if this was a bar graph, right, we would be making bars right here. There'd be a bar right here. Hey, that's what a bar graph would look like. There's one there. There's one there. There's one here. There's my bar graph. So the only difference between a bar graph and a line graph is that instead of having bars, we simply play connect the dots. So all I'm going to do now is connect the dots. So if I connect the dots, well, it's not a bar graph anymore, it's a line graph. And believe it or not, that's the whole deal right there. The difference between a bar graph and a line graph is that I put dots, and instead of bars, I play connect the dots. You can turn a bar graph into a line graph very easily, or a line graph into a bar graph. I'm not sure that they're not going to ask you to do that, but you could. Why would we choose a line graph over a bar graph? Well, remember, a bar graph is going to have bars take up that entire space. So a line graph is a little bit less messy than a bar graph, so to speak. It also gives you an indication just by following the line what's going on. Now you could say, well, I can do the same thing looking at the tops of the bars, but remember, that those bars take up the whole physical space, and you're going to see here in a second. I'll hold this conversation until the next thing we do of why a line graph can sometimes be superior to a bar graph. Now they both say exactly the same thing. What's happening to the data. Let's interpret our data here. So if this is school enrollment, so from 60 all the way up to 1970, boy, looks like the population of school kids were growing. For those of you that know anything about the baby boom, this was the end of the baby boom. So after World War II, well, during World War II, there weren't many babies born. Why? Because all the men were off fighting the war. When the war is over, the men come home, they get married, they have kids. And since they weren't all having kids before, they all had them at the same time. This is the end effect of the baby boom. So after the baby boom is over, right, the kids of the baby boom aren't old enough to get married and have kids. So notice the population goes down. But what happens right around 1985, all those baby boomer kids are now old enough to start having kids themselves. And if you notice, then the population starts going back up. And that's kind of the explanation, historical explanation of why the graph looks that way. No, they're not going to ask you historical questions like that, but I find that kind of interesting. All right, any questions on this graph, line graph, and how to create it? All right. Oh, I forgot to label, didn't I? So remember, it has to have a title. The axes have to be labeled if it's not very clear. 1960, 1970, that's pretty darn clear. But notice the vertical axis, I need to label in millions. It wouldn't hurt to say the bottom is year, but as soon as someone sees 1960, 1970, that's pretty clear. All right. Just as yesterday we made a bar graph, and the very next thing is to make a double bar graph. The same thing today. We made a line graph. The very next thing to do is to make a double line graph. So the definition for double line graph, well, that's a line graph that contains two sets of data points and two lines. Now we say lines, we should really mean curves. Remember, a line is straight and goes on forever in opposite directions. This is more aptly a curve, but they still a curve, mathematically speaking, but they do call it a line graph. All right, so double line graph. Hey, let's make one. Different scenario here. It says money spent on entertainment in the United States from 1940 all the way up to 1980. And notice we don't have one row of data, right? Here's one row. We actually have two rows of data. So they're able to compare two things in one graph. The amount of money spent on going to the movies, that's motion pictures, versus spectators. So they're talking about, hey, you go see the Broncos play or something like that, or anything, an ice hockey game or a baseball game, anything like that. So they are comparing the money in millions of dollars. Notice that we're getting up over, we're getting to $1 billion by 1980, but we start off in the hundreds of millions of dollars. All right, and you can kind of tell from the data that it looks like something's happening. But if we wanted to compare the two, we would make we could make a bar graph if we wanted to, but watch the difference with a line graph. All right, so we got to make our line graph. It's still the same 3 steps. So let's see. Step number 1, put the data in the table. Hey, Merry Christmas, it's there. Step number 2, we got to figure out horizontal and vertical axis. Well, the horizontal one is easy. It's just decades, 40, 50, 60, 70, 80. But the vertical axis is a little bit more interesting. So let's see. The vertical axis. We need to figure out what's the smallest number here. Well, the smallest number here is 98. It's on Spectator Sports, and the largest number is on the motion pictures, and it's 2,899. So, I mean, I guess we could start with a break if we wanted to, but notice I got to go from 100 all the way up to 3,000 basically to encompass all the data point. So this one probably we don't need a break because notice the scale is going to be pretty large there since we need to have both hundreds and thousands. All right, so I'm going to propose that we go by what? By I got to go from 40 to 80, so I don't want to go by 5, so I'll go by tens for my horizontal. So we'll start with 1940, and we'll just go by tens here for my labels. Now notice that I'm not labeling the middle part right here. Why? Because I can leave that as we don't have any data, by the way, either. There's no data for 1945 or 55 or 65. As always, you are the one making the graph. So if you're like, well, that seems like a waste of time, why don't I just make each tick mark 10? You could. All right, so for my vertical axis, well, I'm going to start at 0. I got to go up to 3,000-ish. So if I start at 0 and go all the way up to 3,000, maybe I go by 500s. So 500, 1,000, 1,500, 2,000, 2,500, 3,000. As I said yesterday, this is more art than it is skill. The more of these you do, the more comfortable you will be at picking these scales. You just need to use something reasonable. I guess you could go by 3,000, so you'd have 2 lines, 0 and then 3,000. But boy, would that squeeze your graph down. Could you go by tens? Sure, your graph would be 400 feet tall, right? So there's a happy medium somewhere. You also have to fit your graph inside a physical space. As I said, this becomes more art than it becomes science. All right, let's see what we got here. We're ready to start putting some data. So we're going to do one line at a time. Usually we use different colors when we do this process. So it's kind of hard to see at the start here, but my first data point would be that one right there. I'm going to erase some of the other things that I highlighted. All right, so I need to graph what 735 and at 1940. So at 1940, I'm going to have a dot somewhere where it was 735 is. Well, kind of hard to see, but halfway between 500 and 1,000 would be 750. So it's about halfway, maybe a little bit less. My second point for motion pictures at 1950 is 1367. 1367 would be close to 1,500, but a little bit less. Third point is what? 1960 is right at 1,000, but slightly underneath. Fourth point, 70 is a little bit more than 1,500. And then the last point is a little bit less than 3,000. All right. Play connect the dots, and we get that curve right there. Notice I said curve, not line. And now what we're ready to do is we're ready to do the second point. Well, the second point, I should have done that first one, that circle in, my colors are backwards now. Let me see if I can fix that. So the first time you do it, you are selecting what? You're selecting these two. And the second time around, now I'll do it in blue. The second time around, well, I still need to use 1940, but I'm going to use 98 as my Y value. You see what I'm doing there? So I'm using that number and that number. Oh, that's a big hot mess. All right. No big deal. 1940, we're at 98. Well, 98 is way down there, darn close to 0. But the second point is not. The second point is at 1950 is at 223. Well, that's halfway up to 500. Third point, 354 at 60. 354 is, well, it's closer to 500, but we're not there yet. Notice it was slightly above that other dot. And then we're all the way up to 1,100. No, it's almost 1,200. So 1,200 will be about right there. And then lastly, well, we're at 2,300, 2,300. So that's under 2,500. We're right there. Play connect the dots, and notice we didn't get that big dip, big increase in 1950. So what the heck is happening there? I'm going to go back to the previous idea. So everybody comes back from the war, right? The war ends in 45, 46-ish is when everyone made it back home. So they're back home, they're starting a family, you have a family, right? What do you want to do? You want to go out and enjoy yourself, you go to the movies. Spectator sports at the time, there weren't that many pro teams all around. In the early 50s, right? Everyone couldn't go to an NFL game or an NBA game or baseball game, but they still went to a lot of sports. But notice not as much. Somewhere between the 60s and the 70s, though, you notice that all of a sudden that spectator sports start taking off. This is the growth of our major league sports for spectator sports. Also, things like I don't know racing as well too began a big growth. People started going to auto races and drag races and things like that. So notice as we can see the trend of the red and the blue curves there is that they are both growing at the same rate. After about 1965, they both start growing at the same rate. People still love going to movies, right? More people go to movies than go to an NFL game, though, which is why motion pictures are still king for not in COVID, but you get the idea. Okay, so there is a double line graph. Now we're going to go back to why we like this maybe over a bar graph. Yesterday we did a double bar graph. That's kind of cool. If we're trying to focus specifically on not which is highest, but what's happening to the line itself, it's harder to understand that with a bar graph than it is with a line graph. Like the line graph just yells what's happening with the line. You can look at it, and literally you're looking at where is the line going. With bar graphs, you're kind of focused more on the bar itself, maybe not necessarily how high it is. Certainly, if you want to see differences, which is the highest, which is the lowest, bar graphs are fine. But if you're concentrating specifically on what's the trend, line graphs, rule the roost, so to speak. They are what you use. That said, as always, it is up to you, the creator, to pick which graph you want to use. As we learn more of these graphs, you have more choices of what you should create. And there is no perfect statement of, well, hey, I've got this kind of data. Should I do a bar graph? Should I do a line graph? Or some of the other ones I'm talking about? There's some guidance, right? Clearly, if you don't have categorical data, you just have numerical data, you have more options. But when you do have non-categorical data, this one is numbers, by the way. But if we go back to that, what's your favorite color? You're not going to do a histogram, as we'll learn later, with favorite colors. You got to use a bar graph or a line graph or things like that. I said this was the shortest class of the year. It is because, believe it or not, I didn't do labels again. Sorry. So we got to put our labels on there as well, too. We also need to have an index because nowhere in here on my graph, if I just give you the graph, does it tell you what's the red line represent, what's the blue line. So you see what I have here? Oops, sorry. You see what I have right here is I have a little index that shows the reader which line goes with which set of data points. Okay, so make sure that that's in there. So I did say that today was the shortest class, and that's it. We just did 2 examples, and that's it. So we're ending about, 5 minutes early. Here is your homework. If you have any questions while you're making these graphs, send me a chat. If I'm not teaching, I'll give you an immediate answer. And I'll keep my computer on to about 8 o'clock tonight. If you run into any problems, send me a chat or email. That's it for this week. We're done. It's Friday. Have a good weekend. Remember, Monday we have off, so I will see you guys back in class, normal schedule, obviously e-learning on Tuesday.